doing in this particular assignment is we're reviewing a lot of radical stuff you've already learned. So we're going to basically just be going through the basics. So everybody, the first thing we're going to talk about is rational exponents. Rational means fraction, and then an exponent, obviously, this is an exponent. So rational exponents can be rewritten as radicals, and radicals can be rewritten as rational exponents. So you can literally switch back and forth. They are equal, not one is more simplified than another. So, looking at this, one is not more simplified than the other. Just like standard form of a quadratic is no different than factored form. Does everybody understand? Just different ways. So here's a little trick I use to remember which one is the radical and which one is the power. So the picture of the flower here. This is a dumb little way, but it kind of helps. Roots go on the bottom of the flower, so roots are on the bottom of the fraction. See, look, cube root. And then the power comes from the top, like the sun is the power shining down. Power is on top. So look, this was m to the second power. It's a dumb little trick, but honestly, it helps me remember which one's which. Okay. So just remember the picture of your flower if you're trying to decide. So let's rewrite these. Now, parentheses are a huge important thing when rewriting from radical form to rational exponent form and vice versa. So let's look at the difference in these. Now pay very close attention to the parentheses. So in this one, both 10 and x are both raised to the fifth power, and they're both under the square root, correct? So we would have to write the square root. Now, I would need parentheses of both 10 and x to the fifth power. If I didn't have parentheses, it would be wrong, because if I just had 10x to the fifth, then only x would be raised to the fifth power. Parentheses make a huge difference. So look at this one. This is 10, and then times x to the 5/2 power. Only x is raised to the 5/2 power if I don't have parentheses. This rewritten in radical form would be 10 times the square root of x to the fifth power. So parentheses make a huge difference. Look how different those answers are. All right, so looking at this one down here. Notice something interesting. Both 10 and x to the fifth are under a square root. And then doesn't this x to the fifth power not have anything to do with this 10 to the first power? Not connected. So you would say, okay, they're both under a square root, but then 10 and x to the fifth have their own powers. Does that make sense? 10 is not raised to the fifth power if there's not parentheses. So it's all look good. Now I want you to notice something. The 1 on top doesn't change my exponents because 1 times 5 is 5. 1 times 1 is 1, so we're good to go. So 1 doesn't change anything. 2 is on bottom, making it a root. Okay. All right, so rewriting this in radical form, it has a negative exponent. We would need to fix that. We'd flip bases over a fraction to make them have a positive exponent. So on top I would have a 1, and on bottom it looks like both 2 and x would be raised to the 2/3 power. Do we agree? Same thing, right? That's how we fix negative exponents. So then we would rewrite this as a radical now. So we have a 1 on top, and on bottom we would have a cube root. Make sure you write that 3 tucked in there nice and pretty. And then both 2 and x, both of them, are raised to the second power. Does everybody see? So you have to be able to switch back and forth, rewriting them as each. Now obviously this is not considered simplified to have a radical on bottom, but we did what it asked. It said write it in radical form, we've done that. So depending on what your instructions ask. Now everybody look, a lot of people get confused at this versus this. They're literally the same thing. See, watch. This is x to the parentheses, not parentheses, sorry. So we're doing a fraction. What goes on bottom? 2, because it was a square root. Roots go on bottom. The power is on top, so 7. Now look, let's rewrite this one. My root is 2. My power is 7. So they might write it like this. They might write it like this. They mean the same thing. Everybody see? Okay, sweet. What I want you to do is 1 through 12. Practice writing them both ways. A lot of you already have got it, and a lot of you were thinking, and that's the goal. It's fine if you hadn't got it, but watch. So what you would notice about this one is 3 is not raised to the second power. So we've got to leave these alone. They have their own powers. So we're going to have a 3 and an n squared. Now, why did I put parentheses around those? Because they do have something in common. They're both under the 5th root. So to make it under a 5th root, we would put a fraction and a 5 down here, right? Now, what's the exponent on top that's not going to change this exponent or this exponent? 1, and then because it was on the bottom, it must have been negative. All good? Okay, sweet. Moving on. So now, everybody, now we're actually simplifying. So here we go. It says simplify. Now, I'm seeing some of you out there are moving ahead and doing plus and minuses. This says simplify. If it ever says simplify, it only wants the primary root, which would be the positive root. So we're just going to simplify. Now, here would be a time where rewriting it as a radical would be beneficial. So we know this is the same thing as the square root of 16n squared raised to the first power. So isn't that what we're looking at? Same thing? So this is a time when it would be beneficial to rewrite it as a radical. Because now, what's the square root of 16? Square root of n squared, 4n. Now, you're not allowed to pick up a calculator during this time because we need to be thinking advancedly as honor students. So look at 14. You would say to yourself, I should probably rewrite it as a radical. It's going to be easier to think about this. So you would say to yourself, this is the square root of 81 x to the 4th raised to the 3rd power. You would still not pick up a calculator. You would then say, okay, I can rewrite this. 81 to the 3rd power means 81 times 81 times 81. Now you're not going to actually multiply that out because why? Because then when we refactor it back out. Okay. And now x to the 4th raised to the 3rd power. When you raise a power to a power, you multiply the powers. So that would be x to the 12th. And now remember, because this is a square root, we're pulling out groups of 2. So we'll pull out an 81, won't we? And then 81 breaks down into 9 times 9. So we'll also pull out a 9. So we pulled out an 81, we pulled out a 9. That's multiply them together. That's 729. And then x to the 12th, think about it. We want groups of 2, correct? How many groups of 2 will there be in x to the 12th? 6. So you did 12 divided by 2 and it came out evenly, right? X to the 6th. So there was nothing left under your radical, so we're done. Okay. Look at 23. If you took your calculator and did the square root of 128, it would be a decimal. We're no longer allowed to write decimals when dealing with radicals. So we would break this down by hand into its factorization. Any factors will work, so give me 2 factors that multiply to be 128. I just heard 2 and 64. Now 64 breaks down into 8 times 8. Now understand, 8 could continue to break down, but we're thinking advancedly. Isn't there 2 8s that we're going to be pulling out? So we're going to pull out an 8 for those 2 8s. Don't say we pulled out a 64. Listen, understand what you're doing. You're literally taking the square root of 64, which is 8. You're square rooting it in sections, essentially. Does that make sense of why we only pull out 1 8 for the 2 8s? Okay, so we'll pull out an 8. This 2's got to stay because there's not 2 of them. Now, k to the 3rd, in regular secondary math 3, I write it out like this for them, and I say we're pulling out groups of 2, so when we pull out a k, and then left underneath is a k, but we're not going to do that in here. We're going to think more advancedly. So let's think about it. How many groups of 2 is there in 3? 1. So we're definitely pulling out k to the 1. And then how many is remaining left? 1. So we would say, okay, we pulled out an 8. We pulled out a k to the 1, and then left under our square root was a 2, and we said k to the 1. So watch how I could have done the algebra. I'm just going to show you in this one. Using division. So you'd go off to the side and say, I'm doing 3 when dealing with exponents. 3 divided by 2 equals 1 evenly, correct? But then we have a remainder. So then you would multiply 2 times 1, which is 2. And how many? We add the remainder. How many do we need to add to get back to 3? 1. So look, on the outside was k to the 1, remaining was k to the 1. You see how to do that? Okay, let's do another one. 29. The fifth root of negative 96 x squared y to the 8th. Now, negatives under odd roots are fine. We're going to have a negative answer, right? No i's. You have an odd root, you can have a negative underneath with a negative answer. So now we'll break down 96. So, two factors. 3 times 32. 32 breaks down into 8 times 4, or there's a bunch of others, you're right. And then 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. And then 4 breaks down into 2 times 2. Now, guess what people do? They double dip, I call it. Meaning, they'll say, so we have an 8 under here, a 4, a 2, a 2. Do you see what I'm saying by double dip? If you've rewritten it as something else, it's really not there anymore. Now, we're pulling out groups of 5. So there's 5 2s, so we can leave the house. So when we just pull out 1 2. Okay? And then left under was a 3. So I'm going to kind of go off to the side. We pulled out a 2. Left under our fifth root was so far a 3. Moving on, x squared. Can we pull out 5 of them? No, so we'll have an x squared underneath. And then y to the 8th. Let's do some division. How many groups of 5 are in y to the 8th? 1. So basically we're doing 8 divided by 5, which equals 1, correct? Now what's my remainder? 5 times 1 is 5. How many to get back to 8? 3. So there's 3 remaining inside. So we pulled out a y to the first, and then left underneath was y to the third. Make sense? I don't want to see you writing out 8 y's and circling groups of 5. We're more advanced thinkers than that. And then good point. We almost forgot. We are saved. Thank you, sir. We need to put a negative out here, because if simplified answer would be pulling out the negative. Yeah. All right, practice some like that, of that caliber. There are two cases when you can multiply radicals. First case, if you have the same root, you can always put them together, because it makes sense that we could then rewrite this as 3 times 9, since they both were under a square root. Does that make sense? So then we would say, well, that's the same thing as the square root of 3 times 3 times 3, because 9 is 3 times 3. So then we would say that simplifies to be 3 root 3. We agree. Okay, so if it has the same radical, you can multiply them together. Next case, if you have different radicals, but the same base underneath, we still can multiply these together, technically. Now here's why. We know radicals and rational exponents are equivalent. So this is 3 to the 1/2 power times 3 to the 2/3 power. Am I right? When you multiply the same base, only if you have the same base, you can put them together by adding your exponents. So you would take your calculator, because we don't want to do it by hand, and do 1/2 plus 2/3, which would be equal to 3 to the 7/6. When you multiply, you add. Everybody good? Now from there, you'd say that is my final answer technically, but if you start with a radical, they'll probably want your answer as a radical, and vice versa. Does that make sense? So let's rewrite this as a radical. So that's the 6th root of 3 to the 7th power. And then can't we do one better? Now we know how to simplify, right? So that, as a radical, in simplified form, is actually, how many 3's would I pull out? 1, and then left under the 6th root would be a remainder of 1. So 3 to the 1st would be left over underneath. Right. So now a lot of people will say, well then, can't I rewrite this as 3 to the 1st times 3 to the 1/6? Well, yes, but then you would add your exponents and end right back up there. So you see how it's a never-ending spiral. So stop when you have the simplified radical. Because it started with radicals. Okay. All right, so can we multiply these two together? This is on your worksheet, 37. Yep, same radical, so we can put this together. So we have -2 times the square root of 5 times 20. I'm not actually going to multiply 5 times 20, because then we would re-split it back apart. So now we can just simplify. 20 is 5 times 4. 4 is 2 times 2. And then we're pulling out groups of 2. So won't we pull out a 5 and a 2? And then don't say, well, what about the 4 and the 20? Because those were rewritten as other things. So nothing in this instance was left under the radical. So we had a -2 times a 5 times a 2, which is -20. So that was my final answer there. Yep. And then let's look at these examples. So now let's see if your knowledge is good to go. Could I actually multiply these two together? Yes. Same base. X to the 1/3 times x to the 3/4. Am I right? When you multiply, you add. So we would have x to the 13/12. Does everybody see? And then that would be the 12th root of x to the 13th. So wouldn't that simplify to be x? 12th roots of x. That was really fast. Did you all comprehend it? Okay, moving on. So looking at this, division. Well, this is what you would want to do. You could, right here, right now, rationalize the denominator, but that would be the hard way. The first thing you should do is simplify. So this is x to the 1/3 on top, and on bottom, this is x to the 3/4. And the rule is, when you multiply, you add. When you divide, then you subtract. And you always subtract the top exponent from the bottom. So this is the same thing as this. Everybody see what I'm doing? So then you do 1/3 minus 3/4. So we get x to the negative 5/12, I believe. And then you'd say, my answer started as a radical. It needs to end as a radical. So then from there, we would say, I need to fix the negative exponent before I can rewrite it as a radical. We flip that down. So x to the 5/12 on bottom. So my final answer would be 1 over the 12th root of x to the 5th. Does everybody see? Okay, cool. All right. Okay, let's see if you're going to get tricked on the online homework. Can we multiply these two together? Yep, you would rewrite it 4 to the 1/2 times 4 to the 1/3, correct? I'm not going to continue. You'd be good from there. Moving on, can I put these two together? No, not the same radical, not the same base. How about this one? Not the same radical. What do you guys think? Yes or no? Can I put these together? So everyone's saying no? No one's saying yes. Why? So you're saying 4 is the same thing as 2 squared? Yeah? True. So secretly, can we put these two together? Yeah. Yeah, so you can rewrite one of the bases with the same base as this, then if you can put them as same bases, you can put them together. So this one would be 2 to the 1/2 times 2 to the 2/3, and now we would add our exponents. Does that make sense? But right here, 2 and 3 couldn't be written as the same base, so no. Okay, cool. Do 35 through 44, go for it. Okay, so now we're going to look at rationalizing denominators. Now, you have rationalized denominators in secondary math too, but it's a lot harder in secondary 3. Just because you have to think a little bit more intensely. So everybody, this one is 3 over the cube root of 45. We know it is not considered simplified to have a radical on bottom. Now, here are the steps you should take before you rationalize. You should see if the radical simplifies. If it does, you're going to want to do that first because you're going to want to rationalize the denominator by the lowest amount possible. So let's look. Can we simplify this? 9 times 5, 3 times 3, right? So then we can't pull out anything since there's no groups of 3. However, this is useful because the first thing we should do is rewrite this as its prime factors. So this is 3 over the cube root of 5 times 3 times 3. Is everybody with me? Same thing. Now think about it. How do we undo a cube root? Having something cubed, correct? Because then root would cancel out with power. So now look, when rationalizing the denominator, we're going to choose to multiply by the cube root of, we have 1 5. How many more 5s do we need to multiply by to make it 5 cubed? So we're going to need a 5 times 5, right? Now look on bottom. 5 times 5 times 5 would be 5 cubed. Does everybody see? Now we have 2 3s. How many more 3s do we need? 1. So now on the bottom we also have a 3 cubed. Now if you do that to the bottom, you've got to do it to the top because then you're multiplying by a fancy 1 of your choice. You're not changing the problem. You're just rewriting the problem in a different format. So now look, on top, we have a 5, a 5, a 3, so nothing simplifies. So on top, we have 3 cube root of 25 times 3 is 75. And on bottom, look what we have. Root cancels out with power, cancels out with power. 5 times 3 is 15. And now we know we can divide across a multiplication sign. So this becomes a 1, this becomes a 5. So our final answer would be the cube root of 75 over 5. Everybody good? What was the question? $25 times 3. Okay, let's do another one of that caliber. Number 47. Now, looking at this, we would say, okay, this is really the same thing as 9 over the 4th root of 5 times 5. Unfortunately, it doesn't simplify, so we would just need to rationalize the denominator. This is 4th root, so we need something to be to the 4th power. So we're going to multiply by the 4th root of how many more 5s? 2 more. So now look, it's just a fancy 1, but now we'll multiply out the top. So we have 9 4th roots of 25, which we know didn't simplify since there's only 2 5s. And then on bottom, we now have 5 to the 4th power. The 4th root of 5 to the 4th power is 5. So everybody see how this is working? Kind of cool. Now 9 and 5 don't simplify, so we're done. Okay, let's do another one off the worksheet. Okay, look at 48. So once again, looking at this, we know it would not be appropriate to divide across an addition sign. That would be a huge, big no. Then notice none of our cube roots simplify. So then you should say, okay, well, it's not considered simplified to have a radical on bottom. So we have -1 plus the cube root of 3, that's a 3, all over the cube root of 3 times 3. Because 9 is 3 times 3. So how many more 3's do we need? 1 more. So we're going to multiply by the cube root of 3 to the bottom and to the top. Now careful, I just said to multiply to the top. That means the entire top. So if there's 2 terms, throw in parentheses. Because a lot of people mess that up if they don't. So now multiplying out the top. The cube root of 3 times -1 is negative cube root of 3. Cube root of 3 times cube root of 3 is cube root of 9, right? And now on bottom, didn't we have cube root of 3 cubed? So we have a 3. And then we would be done because we can't add these because they're not like radicals. We can't divide something that's under a radical with something that's not, and so we're done. Okay, sweet. So do some like that. So we'll come back. What I want you to do is do some like that. 45 through 48, go. Okay, there are not any on the homework or on your paper worksheet, but there are some on the online homework like this. So I just want to make sure we're good. So just watch, really, at this point. So just watch these two. Let's go quick. So now look, there's 2 terms times by 2 terms, right? So doesn't that mean we need to double distribute? So let's do this. 2 root 2 times 1 is 2 root 2, am I right? 2 root 2 times positive 3 root 2. Positive 6 root 4, true. Does everyone agree? -3 times 1 is -3. -3 times positive 3 root 2. What did that be? -9 root 2. And now you would simplify and combine like terms. So now notice, this is a multiplication sign. It doesn't become a magic addition sign. So it's 6 times root 4. So that's 6 times 2. 6 times 2 is 12. So we've taken care of that. 12 minus 3. So we have 9. And then look, 2 root 2's minus 9 root 2's is how many root 2's? -7 root 2's. Very good. Now, some people have asked me, so should we kind of write it like A plus BI? And I got where they were going with that. They were asking, should we put it in the format of whole number and then radical? Yes. Because otherwise, your computer might say, rewrite this in a different format. Does that make sense? Okay, cool. All right, looking at this one, would it be appropriate to square that? Square that? No, that'd be breaking the most forbidden rule of all forbidden rules. So we'd have to rewrite this like this. And then let's go super quick through this multiplication. 4 minus 8 root 3 minus 8 root 3. Right, here's where people mess it up. You tell me. Which is 16 times 3, which is 48. So then 48 plus 4, 52. Negative 8 root 3s minus 8 more root 3s. Sweet. Can we combine the 52 and the negative 16? No, it's connected to root 3. Okay, sweet. All right, so we just saw where we were adding like radicals. So this is different than multiplication. With addition and subtraction, two things have to be true. The radical has to be the same, and the base has to be the same. Those are considered like radicals, so we can add them together. So 1 root x plus 1 root x is 2 root x. So we could not combine these by addition. We could by multiplication, right? But not addition. Different roots. Now think about why that is. Can I combine? We all know x squared plus x can't be combined. So it would make sense that x to the 1/3 plus x to the 1/2 can't be combined, right? Okay, down here, even though they're both square roots, we cannot add them. We could multiply them, but we can't add them. Okay. Here we go. Go to number 51. So we have 3 root 3, and then these are like radicals. So how many root 45s do we have? Plus 5 root 45s. Now here's the thing. Maybe we can combine these two. We need to simplify this to see if they're alike. So this breaks down into 9 times 5. 3 times 3. Now be careful. You already had a 5 on the outside. So we pull out a 3 times 5, which is 15 root 5. So we had 3 root 3 plus 15 root 5. Still no, we still can't put them together, but at least our answer is simplified. All good with that? No. Yep, that would be as far as it goes. Let's do 57. So right here, right now, nothing can combine, so we need to start simplifying. So now, really watch the outside. That's where a lot of people mess up. So I pull out a 2. 2 times 2 is 4. So 4 root 6 was the first thing that simplified to be. Okay, next thing. Well, that doesn't need to be simplified, so minus 2 root 5. Now let's simplify this piece. 9 times 5 and 3 times 3. Now watch out, because what was already on the outside? Negative 3. So now we have minus 9 root 5. So it looks like we have two things we can combine. So we have 4 root 6, and then minus 2 root 5s minus 9 root 5s is how many root 5s? Minus 11 root 5s. Does that make sense? Ready to go on your own? Do 51 through 59. Practice a few of that caliber. Difference in the instructions. So in this part of the instructions, it doesn't just say simplify. If you're ever asked to simplify, once again, you would not need to put a plus or minus. You would just put the primary root, a positive root. But in this one, in the directions, it says, so you'll have to pay attention on your homework, it says find all the real square roots. So if possible, we might need to put a plus or minus. Square root of 400 is plus or minus 20. Now we're only talking real. So the square root of a negative 12i, right? Plus or minus 12i, we would not write that. We would say none. No real square roots. They're imaginary. We're not dealing with imaginary in this unit. Find all the real cube roots. Cube root of 216 is 6. Only positive because odd roots don't get plus or minuses. All right, cube root of negative 343. Negative 7. It's okay to have a negative of an odd root. Now, once again, find all the real fourth roots. So wouldn't this be an even root? So we would have I. So once again, no, none. And then the fourth root of 256. You can type into your calculator. If you put a 4, then hit the math key. And then go down to the xth root. That'll tell it fourth root for you. 4. Do we need to put a plus or minus? Yes, since it said all? Yes. Okay. Do 13 through 20 for a little bit of time for the day. So this is brand new to you. I'm almost guaranteeing you've never did this in secondary 2. Probably, most likely. So it says, when simplifying radicals, it might be appropriate to use absolute value symbols. So I'm going to explain when this would be. So everybody look. I'm going to give you an example. I'm going to explain by example. So if we're dealing with the cube root of -8, can't we think of that as the cube root of -2 cubed? Same thing, correct? Cube root of -8 is the same thing as the cube root of -2 cubed, right? So now can't I just go root cancels out with power, so it's -2? Yep, that works. So let's look at an example though. Let's change it to, what if I'm dealing with the square root of -2 squared? Let's use that same idea. Root cancels out with power, we get -2. Well, is that correct? No, that's not correct. Can we ever get a negative when we take a square root? No. So how were we really looking at this technically? We were looking at the square root of +4, weren't we? So it should have been 2. So we would need an absolute value here to make it correct. Does everybody see? So it is +2. So now we're going to apply that to variables. Now one more thing. So notice, if I'm going to change the problem. If we have an even root, my answer is always going to come out positive. Isn't that true? So now look, if I have the fourth root of -2 squared, let's simplify by this method. I meant -2 to the, starting over. Let's do the square root of -2 to the 4th power. What would that simplify to be technically? -2 what? Squared. Now think about it. Isn't this squared going to take care of the negative for us? -2 squared would be +4. So because when we had an even root and our answer came out with an even power, the negative got taken care of. We would not need absolute value. So here's the rule. I'm just going to give you the most basic rule. Now it's kind of interesting. Some pre-calculus books say to do even, even, odd, and then some pre-calculus books just make it simple and say even roots, odd exponent. Let's make it simple. So here's the rule. If you have an even root and your answer simplifies to have an odd exponent, you need to add absolute values, because if it's an odd exponent, couldn't it technically be negative? Will it ever be negative when we simplify? No. So does everybody kind of understand why? It literally only happens in that case. Even roots, odd exponent, then you need absolute values. Because if it's even root and it simplifies to be an even power, the negative is taken care of. All good. Okay, let's practice some of those. So just look, just watch. So for example, what is the simplified form of each radical expression? From here on out, anytime you're simplifying, you will need to add absolute values when necessary. So, square root of 81x to the 4th is what? 9x squared. So let's check here. The rule, let's see if we need absolute values. Is it an even root? Is it an odd exponent? No, so we do not need absolute values. That's taking care of any negatives. Now let's look at this one. The 4th root of x to the 12th, y to the 16th. What does it simplify to be? X cubed, y to the 4th. Now let's check the rule. Even root? Yes. Odd exponent? Then that could potentially be negative, and it's not negative, so we have to put absolute values. Even, so I don't need absolute values. Okay. Even root here? Nope, so you do not need absolute values. You can have negative answers. So we would have a to the 4th, and then b to the 5th. Because it's an odd root, we do not need absolute values. Okay, look at this one. Square root of 16x squared y to the 6th. What's the square root of 16? Square root of x squared. And then y to the 6th, y to the 3rd. Now guys, square root of 16 is 4. That does not need absolute values. 4 is 4. We're good to go. Moving on. Is this an odd degree? 1 and 3 are both odd. So wouldn't I need absolute values around both? Okay. Last example here. Fifth root of 32, y to the 10th, x to the 6th. So we would say 2. Fifth root of 32 is 2. 10 divided by 5 is? So y squared. 6 divided by 5 is? 1x, correct? And then left under my fifth root is an x. Now look, even root? Nope, so we don't need absolute values. Okay, does everybody understand the rule? Practice the ones on the bottom of that section. So I would do 21 through 32, practicing putting in absolute values. So that's what you should do for the last part of class, checking to make sure you understand the idea of absolute values.